Video, we're going to talk about claim, evidence, and reasoning, which is a method that you're going to use in your conclusions for many of the labs that we do in this class. This is a way of writing a scientific explanation. I think you'll also find this method of thinking applicable to many different classes you're taking and many different places in your life. So the first thing we need to do is make a claim. Your claim is usually one sentence long, and it starts your scientific explanation. And it answers the question that you are trying to answer in the lab. So it's going to be describing the relationship between the two variables. In this class, we'll always be looking for a relationship between two variables. And so you're going to describe that relationship. So you're going to be using mathy words. You're going to be using relationship words. Words like linear, proportional, direct, inverse, those kinds of things to explain, to describe the relationship. So I've got an example here. If you think back to the bubble tube lab, we saw bubbles moving at a constant velocity, and we made a graph that looks like this. So our question was something like, how are position and time related when an object moves at a constant speed and has an initial position of 0? So my claim here would be position and time are directly proportional when an object moves at a constant speed and has an initial position of 0. Now, if I didn't have an initial position of 0, I couldn't say directly proportional, but what I could say is a linear relationship. Position and time have a linear relationship when the object moves at a constant speed. There's your claim. Next is evidence. Evidence is where you use your data and your results from your lab to support your claim. Each piece of evidence has to be directly tied to your claim. So not only are you providing me with a graph and an equation, or multiple graphs and multiple equations, but you are telling me exactly how each of those things support your claim. So you're interpreting your data, and you should provide graphs and equations in this part. So let's look back at our example. Our evidence here would be the graph shows a straight line with a constant positive slope and a y-intercept of 0, which indicates a directly proportional relationship. So a directly proportional relationship between position and time. So notice that I have explained what the graph is showing, and then I have restated my claim. I could actually probably add here between position and time. Missed that. So I've stated my piece of evidence, and then I've added exactly how it supports my claim. I've tied my evidence directly to my claim. You could also have a piece of evidence for your equation. So if your equation is x equals 2 meters per second times t, then that equation shows a directly proportional relationship between position and time, which is also supportive evidence that supports your claim. The last piece is reasoning, and this is usually the most tricky one when I'm grading labs and reading them. And your reasoning is where you look at your equation sheet. You get at your equation sheet and you look for an equation that relates the two variables that you were studying. So you're seeing how your lab results tie to accepted scientific knowledge. So this should always be based on scientific principles, accepted understandings, and these are on your equation sheet. You're connecting those scientific principles to your evidence. So you're connecting it all together, and you're connecting that back to the claim. So everything is all connected. So basically what you're going to do is look at your equation sheet, and you're going to find an equation that matches the relationship you found in your lab. And then you're going to explain how your findings support this equation. So when I go to the example here, I have when an object moves at a constant speed, its position is represented by the equation position final equals velocity times time plus position initial. This equation shows a directly proportional relationship between position and time, when initial position is 0. And that is consistent with what we found in our lab. That's consistent with the graph, and that's consistent with our findings. We can also talk about the meaning of the slope, which is sometimes helpful. So the slope represents the constant velocity of the object. And you can talk about how you know that. So we know the units of the slope are meters divided by seconds. It's units of the y divided by units of the x. We're going to get lots of practice on this, but that's just one example.